Good morning, ladies and gentlemen, and a very warm welcome to my talk called Programmers Rejoice, QML Makes Business People Understand. I hope you're not too tired from a long night out in Berlin. But I think I can tell you some interesting things about QML that will keep you awake. So, a few words about me. My name is Hinrich Specht. I'm working for Zürcher Engineering. This is an IT service company based in Zurich in Switzerland with about 600 employees. And we do software and product development, all kinds of, including mechanical and electrical engineering. My focus is on the development of embedded software, especially embedded user interfaces. What you can see there is the last project I've been working on, a kitchen device. Unfortunately not built with Qt, but with Silverlight for Windows Embedded. So I'm looking forward to the next project with Qt. And yeah, that's where I live. That's the city of Hamelin. Well, I think better known for the most of you as the home of the Pied Piper. All right. What am I going to talk about? Well, we are at the Qt Developer Days, so you might have guessed already that I will mention Qt and QML a few times. But that's not all. I will also tell you a little bit about domain-specific languages in general. To give it some kind of structure, I will start with a small introduction as a motivation of the topic. Afterwards, I will show you a real-life example of a project we have done at Zürcher. Then we will talk about the problems you might face when trying to create a domain-specific language. And then see how it might be easier to do this with Qt or QML. We will see a little demo of the QML presentation system, and then dive into extending the QML's type system to create a DSL for ourselves. And at the end of the talk, we will chat a little bit about when might QML be the right choice for you, and when might it be better to use other tools. Okay, let's start with the question. Who is that? Well, not so obvious at the moment, but if you see or hear what he's talking about, then you will understand that this is a stakeholder. He's trying to explain to you what he expects from your software. And since we are software developers and experts, we are trying our very best to interpret this kind of language and to come up with a solution for him. So this is what we answer. And in turn, he might not understand us, but he will say, okay, you're the expert. You will make it right. Software developers tend to come up with solutions and to think in code constructs at a very early stage in a project without even the requirements being fixed. So as we're talking about experts, someone of you know the sketch, the expert. So please do me a favor and Google it afterwards, and then you will see what I mean. It's very funny. But what if stakeholders and software developers could share a common language to better understand each other. And moreover, what would be if changes to the software we built could be made in even that language too? Well, this is a great idea, very idealistic, I think, but maybe we can do some little steps toward this. Let's have a look at a real-life example, as I mentioned before. This is a project we did at Zürcher for a manufacturer of heating systems. This manufacturer builds heating systems for houses, and to improve the systems and how they work. Few systems will be installed every year in a number of houses, and then there will be the new software installed. And then these houses where actual families live in are used as a test environment for the heating system. So the heating system runs and data is gathered, and then comes a new iteration of improvement. This iteration looks something like this. Imagine you have a system that's already running. That's the first draft, maybe the beta version of the software. It's installed in a house. And so now the requirements are adjusted for the first time. Then the manufacturer of the heating systems gave the requirements to a software company, and they implemented the new new features and new parameters and whatever. After that, sure, you have to build and deploy. Then the software had to be rolled out to the test site. And again, the data is gathered for the next step of improvement. So the problem with this was that such an iteration took up to 4 weeks. And sure, this could be only done in winter. So here in Germany, we have maybe 4 to 6 months of testing available. That means 4 to 6 iterations, and that's not very much. So this customer came to us and asked us how to shorten the time needed. What we did basically was we replaced two parts of this. The implementation is no longer done by a software company, but it's done by the customer itself. We developed a domain-specific language that the customer could understand. It was developed with the customer together, actually. And so now the customer is able to make changes to the software very fast. What we found out, what we needed, was some kind of continuous integration, because the build process is very complex. And with these two improvements, the customer is able to adjust the software and have a new build that he can deploy to the test houses within a few hours. That means that the whole iteration now takes less than 1 week. You cannot shorten this anymore, because you will need some time to gather the data and to adjust the requirements, for sure. Well, what you can see is, without diving into technical aspects of this domain-specific language, you can make big improvements with using a domain-specific language. So the question raises, why isn't there a DSL in nearly every project? Well, it's because DSLs may be very hard to develop, because there's many aspects you have to deal with. First, it's the formal definition, like the grammar, the schema, some kind of meta model, abstract syntax, and everything that belongs to a DSL. On the other hand, there's the tooling. It's also very complex because you deal with a lot of tools: parsers, validators, compilers, and editors, development environments, and so on. In the example I mentioned, we used XText. I know. Does someone here know XText or have worked with this with it? No, right. XText is a very powerful language development framework. As it is itself based on a domain-specific language. It is very powerful. You can define your own grammar and syntax and whatever, but it's also very complex. Some steps you need to take when developing a DSL with this is you have to define the syntax and semantics of your DSL. This is done with the DSL XText comes with. It's called grammar. Then you have to configure a generator that creates Java packages and an editor. Java packages because this is an Eclipse-based framework based on Java. There you have MWE2. It's the next language you have to deal with to configure the generator. In the first step, to build the Java packages and the plugin for Eclipse so that you have your editor. We found out that the whole thing makes no sense without continuous integration because it is so complex that you're likely to break your build every time you change the DSL because you have to deploy the editor to all developers in your team every time your DSL changes so that your editor might know the changes. So we did this with setting up Maven builds. Then you have to update Eclipse, and then you can use your domain-specific language. The output of this will always be some Java code. So if you're not targeting Java, you have to do another step. You have to build a generator that creates maybe C, C++, C# code, or whatever. As I said, it's very powerful. What we do, apart from the project I mentioned, is we have a software platform for embedded devices where we can build our basic architecture of. This is also based on XText, and when we go back to the kitchen device I showed you, there are some electronic components with its own processors in it, and with the XText solution, we can build parts of the software for the low-level processing, for the controller board that handles the sensors and actors and so on. We build code for the user interface or for the HMI, and the whole interface for communication between those two. And more than that, we build a complete simulation environment so that we can test the one or the other component without having its counterpart, but only using Windows software as a simulator. So this is a quite extreme example for building domain-specific languages. It's very complicated. There are some frameworks and tools that might be easier, but I wanted to show you what it can lead to. So now, now that we've seen some basic aspects of DSL where it can help, I want to show you a small evolution of programming languages, sorry, to better sort out where QML belongs and what we can do with it. In the early days of computer science, it all started with assembler code. It was tied very strong to the processor instruction set, and you had no chance to do any kind of abstraction. Then came the procedure-oriented imperative languages like C and COBOL. A little better, but yeah, as you all know, not the favorite if you want to do software development and having at the same time a good possibility to communicate with your stakeholders, because he won't understand your C code, I think, if he's not a software developer himself. The next level then were the object-oriented, imperative, general-purpose languages. You all know C++, Java, C#, and so on. Here we got a much better way to abstract things, and we can name our classes like some domain entities the customer talks of. But still you end up with a lot of basic code and glue code that has nothing to do with the domain itself. So you need to have some logging, you have to do some error handling in the language and so on. So this is not what the stakeholder wants to see or can deal with. Then we have some object-oriented, declarative, special purpose, and model-driven languages. It's just a small selection. I took these three because they're very similar. They are all domain-specific languages for the domain of user interface creation. And for those of you who have used QML or one of the other languages mentioned here, it should be clear that this is much easier, because even with those languages, they are kind of domain-specific languages because they contain elements that a designer can deal with. And it's more likely that a designer may understand you when you're talking about the elements used in QML or whatever. So what makes QML, WPF, and Silverlight different? It's one very important thing. QML comes with an extensible type system. So in WPF and Silverlight, sure you can build user controls, but the base of those user controls is always classes that are already there, like rectangles, like whatever, or cute quick controls. So what we really want to do here is extend this type system to have our really own language elements in QML. Let's see what Qt has to offer for us. Well, the extensible type system means that you can use your own custom types in QML. Those types can be backed up by C++ classes. And what convinced me to do this talk today is when I saw this first, that as soon as you have registered a class in QML to use it there, you have the code completion ready in the editor. So you can use your editor very seamless to use your own language elements. Moreover, it's easy to learn because the API needed to do this is quite small and simple. So as a result, the effort needed to create a domain-specific language of your own is very low. There's one limitation. We are talking about very simple domain-specific languages. What you can't do is define your own syntax and grammar. So you will still end up with the syntax of QML. But still, it's a good thing, I think, and we will see. And moreover, in the XText example, we saw that there are at least 4 to 5 different languages you have to deal with. Even at Zülke, where we use this XText-based approach in a number of projects, there is only a very few people who can deal with a whole bunch of languages and tools. This is a real big problem, because if those people are not available, you might end up if something's wrong. So in QML, you can do everything with QML, your own domain-specific language, and C++. Okay, to extend the type system, there are a number of possibilities. Mostly divided into the runtime behavior of the types you create. So you can register types as creatable types. Let's say you have, if we start with QML or Qt quick controls, and you have a list view and type in list view in the editor. Each time you type in list view, a new instance of a list view will be created. And that's the same with a type you register as a creatable type. So in this case, a real instance will be created in memory of your type. Then we have uncreatable types, such as enumerations. You won't have instances of them. Maybe you have a class that contains only a number of enumerations, and you want to use those enumerations, but you don't want to have an instance of the class containing them. Then you can register interfaces, also an uncreatable type, and you can register singletons. So no matter how often you use this type in your QML code, there will only be one instance in memory. One piece of software that makes use of QML's extensible type system is the QmlPresentationSystem that comes from the Qt labs. It's an extension as a DSL for creating slide decks in QML. And, well, it's quite easy to use. Okay, it's from Qt Labs, and I think it's not being developed any more, but so its functionality is quite limited. But it's a good showcase to what is possible there. Okay, I will show you a short demo if I can get my. Yeah, here we go. Here we go. Okay. I think better. Okay. Okay. Okay, basically all you have to do to use this is to import the namespace of the Qt Labs presentation, and then you can start implementing your presentation. And as you can see, here the code completion is already available. So ID is presentation, and we can okay, it has a height of let's say this one, and a width. Oh, sorry, I mixed it up. No, sorry. Okay, and then you can start adding slides. Slides also have might have a title. My first slide. And then you have some content. This is because you can have more than one line. It looks like this. It's my content. I hope I did it right. Oh, this is the wrong one. I'm sorry. But why? Okay. No. Okay, it's a show effect. Excuse me? Sorry for that. No, just some other errors. Okay, not to not lose too much time. We would just take the thing that's in here. So I've prepared a little bit. Okay, so basically we have a presentation coming with a number of slides. You can have images in there and some content. And I hope it will be working now. This is not the one. Oh, maybe I messed up some things in the build. Okay, so but that's not the output. The real presentation is not the very important thing. The important thing is that you can have those elements that were custom defined, the presentation and slides, and there are some more things. Maybe I can, yeah, it should be there. You can also have some. No, it's just a single one. Okay. Okay, doesn't matter. But this is what I wanted to say. So you have there are elements like code slides where you can put code in it, and you get line numbering without typing it. So and you can highlight single lines of code in there. So this is one basic example of what you can do with it. But as it is presentation system, it's still very close to user interface construction that you do with QML anyway. But I want to show you how to use other elements, how to use QML in another way. Not just for creating user interfaces, but also for doing some other things in your software. Okay, first have a look how custom types are being used in QML. One thing you have to do, let's say you have a plain old C++ class. You have to derive your type from a QObject to make it available to QML. Then you can define properties that should be available in QML. When thinking about the slides, it may be the content property or whatever. You can define the property name, you can define getter and setter methods, and also the name of the member within the class. What you have to do then is register your type in QML with one of the methods I've shown before. You have to provide a namespace which to import to use your type, and a type name under which this type should be available in QML. Then you have to run qmake, because to make those types available in QML, the meta objects have to be built, and this is done with qmake. Then you can import your custom namespace in your QML file, and that's all. You're ready to use your custom type there. Very easy for that. Here we saw the version where you register a creatable type. So every time you do this, it will create a new instance. To register singleton types, there are two ways to do it. It's 3 ways, but basically you have to you can register QObject types and QJS value types for use in QML. The method to do this looks very similar, except that the type is different there. So it's basically the same way. And you can also register types that are defined in QML. Say you don't have a C++ class yet, only a QML file where you define the type, and want to use it, then you can also register a QML defined type as a singleton. Okay, to use uncreatable types, the method call, API call looks very similar again. So it's only a QML register uncreatable type, and there you can use this maybe for using enums. One important note is to use an enum, it must be wrapped in a C++ class, because as you have seen, to register a type, it must be derived from QObject, and you can not derive a standalone enum from QObject. Okay, some drawbacks you have to deal with. As I said, you can. It's basically a way to create a simple DSL, and there are some things that are not so nice, and probably you don't want to give the DSL you created with QML to your customer. Maybe because since our types are derived from QObject, within QML, all properties that are available to QML from QObject are also there. So you cannot limit the properties of your type to the ones you define. There are also many others, and they are not always wanted in your domain-specific language. Let's say you have an element or a class defining whatever, a state in a state machine, and you can't get rid of the X and Y properties used in QML. So that's not, it could be, there's room for improvement, I would say. Okay, then if you are not targeting C++ or even C++ with Qt code to use your DSL in, then you have the problem that there is no integrated code generator for generating maybe C code or whatever you want. So, and this can become quite a big problem, or at least you will have to spend a lot of effort to do this. Okay, one thing I found out when building my example was that the editor is not always as smart as it could be. So when I tried to register some singleton types, I found out that the code completion did not work as is expected. But I think these are some minor issues. Okay, and as I already mentioned, you have a fixed syntax. Let's see how it works. I've prepared a small example. I hope this one will be working a bit better. Okay, as an small introduction, since I come from the embedded software development, one part of the embedded software platform based on XText we have is that we can define a data layer of an embedded system via DSL. So the data layer contains data elements. Data elements are basically variables, but not only the variables itself, but also their getter and setter methods and additional information where those variables should be visible. Should they be visible in the user interface, or should they only be visible internal or to other components of the system, and so on. On the hardware side, or very, very close to the hardware, is the hardware layer, or hardware abstraction layer. I've simplified this example. So you may have some GPIOs. There's inputs and outputs a processor has, maybe for controlling outputs like LEDs, motors, and whatever there is. And on the other hand, for receiving input like some switches, if you close a door, or have a sensor for temperatures or whatsoever. And there's a data switch between them that is responsible for passing data around between those layers. Okay, and I tried to build some parts of this in my small example. So let's see what we got there. Okay, the goal is to have a very easy way to define the data layer and to define the hardware layer, the GPIOs I have there, and to define in which direction data should be passed. Should it be an output or an input parameter, or variable. To do this, I have defined some basic elements. The first one is the data element. This is the one containing the variable I have in the system. This can be an engine speed, or a value indicating if a door is closed or whatever. So here you can see this type is derived from QObject. It defines some properties with a QProperty macro. So this means that those variables those members will be available in QML also. And then I have a static declare QML method in there that calls the register type for itself. Okay, some slots and signals, that's basically all I have to do. There's not much behavior in those classes. The next one, basically the same. I think I don't need to explain very much about this, is the GPIO. It also is derived from QObject. It defines some properties like a display name and a value, and an identifier. The same with the data element. And to collect those data elements on the one hand and the GPIOs on the other hand, I've introduced data layer that basically contains a map of data element IDs that point to data elements, so very simple one. And the GPIO or the hardware layer is the same for the other side. Okay, so this is the basic objects we deal with, and let's see our main method, not the main QML, but the main method. Okay, what we do here is we call declare QML for all our types, and once we have done this, the types are available in QML. So this is basically all you have to do to get your own types available in QML. The whole bunch of things that is coming now is only to have a better showcase to see things working, but this is basically what you have to do. Okay, let's see. Now we come to the part of the domain-specific language we've defined with where. Now we come to where we want to use it, and therefore I have I've built 3 QML files. One containing the data elements, very simple one. I have some data elements, and I define the actual display names and values and the identifier. Very simple one. On the other hand, I have the list of GPIOs. Here I can define which GPIOs my embedded processor provides and how they, what their ID is. To keep it simple, I've only used Boolean values here, so you might end up with some more information about what kind of value you get there. Is it a digital value or is it an analog value? Whatever. Okay, so just a list of GPIOs. If you want to add another one, it's a GPIO, and you can have display name. This is GPIO Qt, and the value is true, and the identifier should be GPIO IDs. And here you can see the GPIO IDs is actually an enumeration I have registered with QML. I can show you. It's just registered with register uncreatable type, and it's wrapped in those GPIO IDs class. And I have to for this reason I have to reference it by GPIO IDs and then the number of it. Okay, maybe we take the 1. What I don't have in here is a check if there's a double assignment. Okay. So this one should be available. Let's have a look. We should have another data element here. Data element, display name is Qt. Cool. Value should be always true. Identifier is data element IDs. Oh, I've forgotten to define a value here. So what you can see here is that this is a thing where the power of a bigger DSL creation framework comes in, because here we have to define the enum values. We could use other things to identify those, but in a more complex system, there should be a way to define the enum values and then do some kind of code generation and then have the enum values available in your DSL. This is not the case here. Okay. For okay, data element IDs. This is the data element IDs. Here's my enum, defining the IDs for the data elements, and this is actual value is cute, cool. All right, and let's see data elements QML. Very cool. The value is immediately available in QML. Okay. So now we have defined a new GPIO and a new data element, and now we are going to configure those within a GPIO mapping, so we can say that those two should be connected. We have a GPIO direction, is the GPIO mapping. Here you can see all the properties I typically don't want to see within my DSL. So this is a kind of drawback here. This is GPIO out and the GPIO ID. ID is GPIO IDs. Where is it? Sorry. 11 GPIO, not data element ID is data element IDs. Actual value is cute, cool. Okay, here we go. Okay, here you can see that it's very easy to have your own kind of description of a system within QML, and all this has nothing to do with UI user interface creation. There's no description of how it should look like in a user interface. Maybe you only want to describe your data layer or whatever. So what I want to do you is to think about can I use QML for something like this in my project? Because in my opinion, this is a very powerful feature. For completeness, I will show you what I've done. Okay, I've changed the enumeration, so I have to build. Okay, I have built a small UI to see it in action. I will show you. I hope everything will be there. Yeah, so yeah, okay, here we have it. So this is a representation of those of this GPIO to data element mapping, and depending on the direction we defined, we have a button. Here we can. This is an input value. We can change the GPIO value, and oh, that's the wrong mapping, I think. Okay, but on the other hand, you can, for an output value, you can change the data element, and in this case, the fan should be off. All right, that's it for the demo. And there's only one more thing. I think we are a little bit late in time. Okay. When might QML a QML-based DSL be the right choice? Well, I speed up things a little bit. I think there's two kinds of domains. One is the stakeholders domains, typically things like accounting, the heating system, whatever. But there are also other domains we are dealing with every day. So these are our technical domains, like state machines, like user interface creation, like system composition, data layers, and whatever. So it may be worth thinking about a domain-specific language, not only if a stakeholder comes and says I have a problem, but also for your daily work to ease your life. And especially think of QML-based DSL when other tools might require too much effort, and you might be satisfied with simple features of the DSL when you don't need any code generation for targeting other languages, and if the DSL will mainly be used to define static aspects. Sure, you can implement behavior. QML allows you to implement JavaScript, but then it becomes a little bit harder to see it as a DSL, because then you have to deal with the code constructs that JavaScript provides. Okay, on the other hand, when you need your own syntax and semantics and code generation for different languages as required and so on, then it might be worth to take a look at other frameworks for generating languages. Okay, so far from my side, any questions? Yeah.
Just thinking about the example that you have shown, the GPIO and data, and the other element, is this, one could do this also with a C++ class, and then have getter and setter just one class for each domain of this part you mentioned, and despite the more easier editor and maybe the easier or faster running to start from creator, I don't see the large difference. Maybe I'm just overlooking something, or there's if we extend this then.
No, it's just a starting point here. Sure, you could use quite a handful of other things. You could use XML with a parser, define a schema, and you basically, with a powerful XML editor, you would have nearly the same functionality at first glance. But as we are dealing with C++ every day, and this is a very there's not much effort to do to make the types available to QML, and I think from my experience it may be very helpful to have a quite simpler interface to implement some parts of your software. So especially for the thing I have shown you, this is with the support of the editor, it's a good start. But we are actually trying to think a little bit further, but it's we are not finished yet. But how to use it to really implement behavioral aspects of the language and to get more of it. Also using maybe a simple kind of code generator. So then it becomes more interesting, indeed. Yeah.
Could you just for the coding?
Did you run into performance problems for about if you have 100 or objects or something, or 100 properties? No. Embedded systems.
No, the parser is quite fast. And but I must admit that I have not tried to bring it to its limits. So it would be worth a look to see how it behaves under a heavy load. Yeah. Yeah.
You have mentioned that you can register types and creatable, uncreatable types, singletons, and then you also mentioned interface.
Mm-hmm.
And I just don't know what QML interface is, so maybe you can just explain in short.
Yeah, you could. You can, as you would do in C++, you can define an interface in one part of your QML code, even if you don't know what kind of instance type you will have later on. So this is just to have a possibility to pass different things around. Think of it just as you would in C++ would do in C++ with abstract classes or yeah.
So it would be a class without data members.
Yeah, it's just.
But there's no special call in C++ to register interface.
There is a call to register an interface. Okay. Yeah, but as it is with a singleton, when you register a singleton from a C++ class in QML, the C++ class does not have to be a singleton implementation in C++. That's the point. You know, you can. All you have to provide is a provider method to create an instance, but the constructor doesn't have to be private in this case. You can register it in QML, and QML treats this type as a singleton inside the QML world, and that's the same basically for interfaces. So you won't have, you can register an interface, and it won't create an instance of it, but know what properties and methods you have in there. Yeah.
Did you try this on different domains?
Especially with QML, or?
Yes.
No, I didn't. This is just, as I said, a starting point for us to. What we have experienced is that the approach we took with XText is suitable for projects with about 10 developers or so whatsoever, because then you can afford the overhead needed to create and more than that maintain the domain-specific language. What I was looking for is a much simpler approach to get at least part of the DSL stuff done with much less effort. So, but I'm sure I will take a deeper look at in the next project. So, unfortunately, as I said, my last project was with Silverlight on Windows Embedded and no Qt, so I had no chance to give it a try in real life yet. Okay, time is over. Thank you for being here. Enjoy your day. Thank you very much.